For this lesson, we're going to continue going through some examples of solving some different trig identities. So let's start with this example here. Sine squared theta all over 1 minus cos theta equals 1 plus cos theta. So remember, the first thing that we want to do is we want to choose the side that we're going to work with. And we want to choose the side that looks a little bit more complicated. So in this case, that would be the right side. So that is the side that we're going to work with and manipulate to try to look like the right side. So the first thing that we want to do is we want to think about some things that we're going to have to remove of or get rid of. So we're going to need to get rid of that sine squared theta, and we're going to have to figure out how to change that denominator a little bit. So because we don't have a 1 plus cosine theta anywhere, this is a situation where we're going to just add in what we need and then see if things simplify. This works very often. However, sometimes it doesn't, but it's always worth giving a try. So what we're going to do to start is I'm just going to multiply by what I need. So I'm just going to multiply by 1 plus cosine theta all over 1 plus cosine theta. And the reason why I multiply by the same numerator over the same denominator is so that it's the same as me multiplying by 1. So now if I multiply that, I will have sine squared theta times 1 plus cosine theta in the numerator. And in the denominator, I have 1 minus cosine theta being multiplied by 1 plus cosine theta. So that is just our difference of squares. So that would simplify to 1 minus cosine squared theta. Now, if you went through and actually did FOIL and used your arrows and multiplied it all out, you would get there. So if you are having a hard time seeing the difference of squares and you fully multiply it out, that's absolutely okay. All right, so if I look here, I'm going to see what else I could potentially cancel out. So if I look, I have to somehow get rid of my denominator. And I look in my numerator and see if there's anything there I could maybe switch. And that sine squared theta, if I remember my Pythagorean identity, can switch to 1 minus cosine squared theta. And we haven't changed anything in the numerator. So now I have a 1 minus cosine theta in numerator and 1 in the denominator. So those can cancel out. And I'm left with 1 plus cosine theta, which is exactly what we were looking for. So I can say that my left side equals my right side, and that would be my final answer. So if you are having a hard time, remember this fraction trick here. There are a few tricks when doing trig identities, and that is one of them that's very beneficial. For our second example, we have sine theta over cosine theta plus cosine theta over sine theta equals tan theta over sine squared theta. So the first thing we do is we choose the side that we think is more complex to manipulate. So in this case, it's going to be the left side because we have fractions being added, which definitely makes this more complex. So let's start by adding these fractions. So when we add fractions, the first thing we need are common denominators. So my lowest common denominator is cosine theta sine theta. So this first one we need to multiply by sine theta. And what we do to the denominator, we have to do to the numerator. Same thing on this side. We have to multiply by cosine theta for both the numerator and the denominator. So that will give me sine squared theta over sine theta cosine theta plus cosine squared theta all over sine theta cosine theta. And we're still trying to make this equal to tan theta over sine squared theta. So when I add fractions, I keep my denominator and I add my numerators. And now in my numerator there, I have my Pythagorean identity. So I can write this as 1 over sine theta cosine theta equals tan theta all over sine squared theta. Now at this stage, I need to figure out how to get a tan into my answer. So somehow I need a tan in my answer and a cosine to leave the other side. So what we're going to do is we're going to try to figure out how tan and cos are related. So we already know that tan theta equals sine theta over cosine theta. Now I'm going to rearrange this a little bit to see if I can use it to try to figure out this trig identity. So I'm going to move my cosine to the other side. So it was being divided, so I just multiplied it to move it. And now if I try to isolate cosine, I can just divide both sides by tan. So now that gives me a way to get rid of a cosine on my left side of my trig identity and put a tan in. So because I'm going to be dealing with fractions, I'm just going to quickly write this like this. Sometimes when you're dealing with fractions, it's a little bit easier if you write it like that, so we don't have fractions over fractions. So now here, instead of writing a cosine, I'm going to write all of this stuff here. So I'm going to have 1 divided by sine theta times sine theta all over tan theta. And we're still trying to make that equal to tan theta over sine squared theta. So now I'm just going to multiply sine squared theta over tan theta. And we're getting really close. So remember, when I divide fractions, I flip the second one and multiply. So that's what we're going to do. And we're just multiplying by 1, so we can get rid of that. So we'll end up with tan theta all over sine squared theta. So now we have that our left side is equal to our right side, which is exactly what we wanted. For our third example, we have 1 plus tan squared theta over 1 minus tan squared theta equals 1 over cosine squared theta minus sine squared theta. So the first thing we want to do is we want to choose our more complicated side to manipulate, which in this case, because I have tans, is definitely the left side. So the first thing I'm going to do to make our lives a little easier is I'm going to write it out like this. Now you don't have to do this step, but I find as soon as we have fractions over fractions, people have a tendency to get really confused. Now I'm not going to have a ton of space to keep writing out my whole right side, so we might just have to remember that it's there. Okay, so the first thing I want to do on my left side is I want to get rid of my tans. And the reason I want to do that is because on the right side, we just have sine and cosine. So because there's no tans on the right side, we'd like to ideally get rid of it. So let's put our tans in terms of sines and cosines. So we'll have 1 plus sine squared theta over cosine squared theta divided by 1 minus sine squared theta all over cosine squared theta, just like that. And I'll try to fit these in. There we go. Now, inside each of those brackets, what we're going to do is we're going to make some common denominators. So for both of my brackets, my common denominator is cosine squared. So instead of writing ones, I'm just going to write cosine squared theta over cosine squared theta like this. So again, all I'm doing is I'm just making common denominators so that I can add these things or subtract them in the brackets. And we're still trying to equal 1 over cosine squared theta minus sine squared theta. All right, so let's simplify those brackets. So when we're adding and subtracting, we keep our denominators and we add or subtract our numerators. There's our first one, our second one, we're still trying to equal our right side term here. Now, what we're going to do is I can change this here to a 1, so I will do that. And I will also divide these. So when we divide, we flip the second one and multiply. So let's do that as well. So we flip the second one and multiply. Now we see some things are canceling out here, so that is a very good sign. So I'm going to cancel my cosine squareds out, and I'm left with 1 over cosine squared theta minus sine squared theta, which is exactly what I wanted. And we managed to fit that one on the right in the space we had, so that was an added bonus. And then we have that our left side equals our right side, so we're done. For our last example, we have cotangent theta all over cosecant theta minus 1 plus cotangent theta all over cosecant theta plus 1. And we're going to see if we can make that equal to secant theta. So the first thing we need to do is we need to make some common denominators. So our lowest common denominator will be cosecant theta minus 1 times cosecant theta plus 1. So when we make our common denominators, we'll get cotangent theta multiplied by cosecant theta plus 1 plus cotangent theta times cosecant theta minus 1 all over our common denominator of cosecant theta minus 1 cosecant theta plus 1. And we're still trying to make that equal to 2 secant theta. Now what we're going to do is let's multiply in those cotangents so that we can simplify some things. So we'll have cotangent theta, cosecant theta, plus cotangent theta, plus cotangent theta, cosecant theta, minus cotangent theta. And let's simplify the bottom as well. So we have cosecant theta minus 1 times cosecant theta plus 1. And that is a difference of squares. So we can simplify right to this. And we're still trying to make it equal to 2 secant theta. Now, in our numerator, we can simplify this a bit. So we can cancel out those. And we're left with 2 cotangent theta, cosecant theta, all over cosecant squared theta minus 1, which is equal to 2 secant theta, where we're trying to show it's equal to that. So now what we want to do is we want to see what cancels here. And it's very hard to do when we're using our cotangents, cosecants, and secants on the other side. So what we're going to do is we're going to use our reciprocal functions to see what will cancel out. So because I'm going to be using reciprocals, which means fractions and fractions, I'm going to rewrite this like this, just so that it makes things a little bit easier once we put these fractions in here. So now let's put in our reciprocal ratios. So we'll have 2 times cosine theta over sine theta multiplied by 1 over sine theta. And all of that is divided by my cosecant, which is 1 over sine squared theta minus 1, and we're still trying to make that equal to 2 secant theta. Now what we're going to do is we are going to make common denominators here to simplify this before we do the division. So on this side, we can cancel out these, just kidding. We're going to leave it as cosine theta over sine theta multiplied by 1 over sine theta divided by 1 over sine squared theta, and we're going to make some common denominators here. And we're still trying to make this, oops, sorry about that. I wrote a cosine, and we're still trying to make this equal to 2 secant theta. So now this side, I'm just simplifying this side a little bit, divided by 1 minus sine squared theta all over sine squared theta. Now, this here, we know we can write as cosine theta, so let's quickly change that. And while we're at it, we are just going to flip our second fraction and multiply. And now we can see that things are canceling. So it's a really good sign that we're almost done. So now we have some things that cancel. My sines cancel like that. And then one of my cosines cancel. So I'm going to be left with 2 over cosine theta, which, because that secant is my reciprocal function of cosine, I'm left with 2 secant theta equals 2 secant theta. So that one is a very long one, so you need to be patient, but if you keep working through it, you will get there.